I wanted to give a brief video update to help you all with regression interpretation, which is, of course, where you want to end the assignment, and just to sort of give you the very basics of the interpretation. Regression analysis is pretty much a staple of of all the health professions. You're going to see it in posters, you're going to see it in papers, you will see it in published articles and so forth, refereed articles. So whether it's epidemiology, in which there are what are called survival models and hazard models, whether it's in health-related survey research, healthcare marketing, it's there. So it's good to know what we're doing with it. And so first, we always have sort of at least one causal variable, which we'll call X, and the response variable. I'll try to sort of do some highlighting as I go along here. Only I like fun highlight colors. So we have our cause and response, X and Y, and oftentimes you'll hear that these data are fixed, and we don't mean by that that the data have something were massaged or made into something else. All that means is that we've already gone out and collected the data, and we take them at their given values at this point. You can extrapolate data or transform it. I'm sorry, now I'm getting some background noise, which I want to just stop for a second. Actually, I'll just keep going, and that will get picked up if you give me just a minute. But then we come to our basic data equation, which is here, which is that the response variable y is going to be equal to the intercept, which I call b sub 0, plus b1 times the independent variable x1. And so b1 then is considered to be the slope of this, and we understand that b0 is maybe what you would call the baseline, or actually the basis point for where y would start in the absence of any x at all. So the intercept is the value, that's this sentence here. The intercept is simply the value that y would take if x were equal to 0. And this is the point at which the regression line would cross the y-axis, or the response variable axis. And so if you're estimating length of the stay in the hospital, and we have a b sub 0 of 2.1, then we would expect, and we want to know length of stay in the hospital based upon age, we would say that length of stay in the hospital is b sub 0 is 2.1. So a newborn, we would expect to be in the hospital 2.1 days. And then if we wanted to interpret the equation, where we have this third piece here, where length of stay equals b sub 0 plus b1 at age of admission, one thing you can do is actually plug in real values for the age at admission. And so length of stay could be equal to 2.1 plus 0.13 days per year at age of admission. And if that were the case, then a 55-year-old we would estimate that would stay 2.1 days plus 55 times 0.13, which is 7.15 days, so that a 55-year-old would have an expected hospital stay of 9.25 days. You can do the same thing then with years of life lost in New Mexico, where if you have a given income ratio, let's say of 5, and it might be an intercept of 1.5, it would be 1.5 plus the slope of 5 let's say the slope is 0.3. 0.3 times 5 is 1.5. So we would estimate that 3 years of life are lost in counties that have a income ratio of 5. If we would have a 93-year-old, we would expect them to be in the hospital just a bit longer, obviously, than a 55-year-old, not just a bit, actually 5 days longer, where we have the same 2.1, the intercept remains the same, and then the slope remains the same at 0.13 days per year, and then a 93-year-old. And so we then get 2.1 days as the intercept plus 12.09 days for the 93-year-old, and we would estimate a 14.19 day hospital stay. So again, I hope that this is helpful to you, and that we can, if not, that we'll find other